Well, good morning again, everyone. As I said at the outset, I'm Tim Eder. I'm Executive Director of the Great Lakes Commission. I'll be moderating the webinar today, and joining me here are Leon Carl, the Midwest Regional Director for the U.S. Geological Survey. Also with us are Bob Lamb, Executive Secretary for the Great Lakes Fishery Commission, and John Bratton with NOAA's Great Lakes Environmental Research Laboratory, and Mark Gaikowski. Mark is the Center Director for the Upper Midwest Environmental Sciences Center at USGS, and you'll be hearing from all of those folks a little bit later on this morning. So the purpose of our webinar is to share information and answer questions regarding a new Invasive Mussels Collaborative being established by the four entities that I just named: the Great Lakes Commission, U.S. Geological Survey, Great Lakes Fishery Commission, and NOAA, National Oceanic and Atmospheric Administration. So our agenda for this morning includes an overview presentation outlining our ideas for the collaborative, and I should stress that they are ideas. We have some proposals, but they should be considered ideas and draft, and we welcome your input. As well, we're going to be hearing a review of the recent science and research related to control of zebra and quagga mussels. And at the end of the webinar, we have plenty of time planned for some questions and hopefully some answers. Before I begin, I just want to cover some logistics. We have quite a few people registered for the webinar today. We had over 125 people registered, and many people are from the West, so I welcome all the folks from all of you, but especially those that are with us from the western part of the United States. So everyone has been muted today to avoid background noise. We are recording the webinar, and we will make it available on the Invasive Mussel Collaborative website, which is up. Once the presentations are concluded, there will be time for questions from participants, and we'll do our best to take all questions during the webinar. To ask a question, you have two options. The first option is to click on the button to raise hand. You see a little hand icon. I believe it's in the upper right of your screen. We will call on individuals with raised hands one by one. All attendees' audio lines will be muted during the presentation. We will unmute your line when we are ready to take your question. Don't forget to unmute your own phone if you've muted it on your end. Second option for asking a question is to submit in writing through the questions box. You may submit questions this way at any time during the webinar. Please be patient, and we'll do our best to respond to all of your questions. Do we have an hour or 90 minutes scheduled for this, Erica?
We've set an hour.
Okay, we'll try to get everybody in an hour. I think we have a little bit of extra time if we go over. So with that, I'm pleased to turn it to Leon Carl with the U.S. Geological Survey.
Thanks, Tim, and good morning, everyone. I will tell you that the presentations are short, so we're hoping to have lots of time for questions later on. But I also would like to say that we are all excited about sharing this information today, and we're really looking at beginning to build a collaborative with all the partners, and a strong collaborative as we move forward on this issue. If you look at the side, and I'm going to probably talk about dracenids rather than talk about zebra and quaggas, just for simplicity. Most of you know the invasion of dracenids originated in the Great Lakes, but now it's a national and an international problem. And the way that we have talked about this among the four partners and quite a few other people that we've talked about is that we really want to step up for this collaborative. It's a problem that originated in the Great Lakes, and we want to be part of any solution that we come up with. So I just wanted to put that in as we move forward with this. The effects of quagga and zebra dracenids, again, we see changes in water clarity. There's definitely impacts to food webs, food sources for fish. In some cases, we're seeing gobies and whitefish and other species are eating the mussels. We're not saying it's a good food source, but they are using that. There's definitely an infrastructure impact that we're seeing all along the place. And probably one of the biggest thing is the scope of the problem itself. The magnitude is very, very large as we move forward with that. And we're going to probably and primarily be focusing on some of the ecosystem and infrastructure effects. I know there's a lot of other work going on throughout the country we're looking at some of the opportunities that we may be having as we move forward. If I just summarized it, I hope you aren't insulted, but I look at this as a long-term and a profoundly negative impact that's happened on the ecosystem, and even, frankly, some acceptance at the ecosystem level because there was no real alternative to these mussels as we move forward. And now I would state that there is some cautious optimism, and more importantly, I think it's in time for all the partners to get together to look at addressing this issue with adequate resources. And I can't stress that enough, is that we're going to need adequate resources to move forward on this. And part of the reason for that optimism, as many of you are, I'm sure, aware of, is that a selective toxin, it's called Zequinox, has been approved by the EPA for open water use. There have been trial applications in the ecosystem in Minnesota, Michigan, and Wisconsin. And we are also in the process of developing other technologies, again, for ecosystem use. I know there's a lot of work going on looking at infrastructure and other things, and we're definitely looking at this as an integrated pest management approach and a long-term effort moving forward. When I look at one of the reasons that we're looking at this is Invasive Mussel Collaborative. It's going to be a tough management issue. It's potentially multi-jurisdictional, it's multi-sector, and it's a management challenge that we have to look at very closely as we move forward. And it's also the question that we kind of bounced around a lot among the four groups that's originated this was, what is the most effective way to bring the agencies together on management and science objectives related to create a potentially powerful management tool? And you notice we kept that pretty broad, and we've kept it quite inclusive because we really want to get everybody involved with this as we move this forward. I think that will be the most efficient way to do this and not have a lot of individual efforts. And that third point, the collective impacts, how do we bring multiple interested parties into a common understanding and common agenda moving forward? There's been several agencies here in the Midwest that have used some research that's come out of some of the social sciences that talks about a framework for addressing very difficult problems. We have used it here in the Great Lakes on 2 or 3 large-scale issues, and we've been pretty successful with that, and we're hoping to use this approach, and we can give you references on it as we move this forward. And I'm going to turn it back over to Tim right now. Thanks.
Okay, thanks, Leon. So the Mussel Collaborative, as we've defined it thus far, we've identified an overall purpose, which you see on this slide at the top, providing a framework for communication, coordination, to determine management objectives, and to identify and guide research needed. So I think it's that those two elements, identifying management objectives and guiding research, and the way the two of them work together. The management will identify science priorities, the science work will identify management tools, and so on. And so we envision a feedback loop to inform both sides of the effort. The objectives are identified there: facilitating information exchange, developing a joint and strategic approach, and implementing communication and outreach activities. These are the founders and what we're thinking about in terms of membership. Again, very much subject to your input and improvement as we go forward. You see the 4 principal agencies that have planned and initiated the effort thus far, proposed members in the middle, U.S., Canada, tribes, state and provincial agencies, NGOs, industry and academia. And then we recognize that there are going to be many external connections, sort of a broader list of public and others, local lake associations, the general public, and a really important audience for this is going to be the U.S. Congress. We expect Congress is going to be very interested in this. There is a new invasive species caucus in Congress, and of course much of the funding for much of our work to manage and prevent and try to anticipate invasive species is coming from congressional support. So that will be a real important audience. This slide is a little bit complicated, but you see the egg here, which shows the general structure of the collaborative as it is envisioned at this time. The science team on the far right with the steering committee in the middle, And you see the arrows going back and forth with the steering committee identifying science priorities, the science team identifying results of science and informing and assisting with the development of decision-making and management activities. Along the bottom of this slide, you see that's where our organizations, the principals that have initiated this, are trying to incubate it, the neutral backbone. And we're starting this in the Great Lakes, but we recognize that there are many people from the West, which we're really excited about, and we welcome your interest and participation. But we've got to start this somewhere, so we're incubating it here in the Great Lakes and looking to expand and include other parts of the country and even internationally as we go. These are some of the thoughts that we've identified in terms of science questions and how we've grouped them to date. And again, once we get the collaborative together, we're anticipating holding a meeting in February. But once we get the science team and the steering committee together, we will have an opportunity to refine these questions, add to them, and so on. Developing models and decision support tools, and a really important one there in the middle, understanding better the relationship between mussels and harmful algal blooms. I know many of our jurisdictions here in the Great Lakes region are very concerned about harmful algal blooms, and understanding the connection not only between mussels but also between the potential to control mussels. And then over on the far right box, optimizing biocontrol and application procedures, kind of the technologies. And I guess one of the things that I would emphasize, I suspect Mark will make this point as well, but we see this as an opportunity that's kind of stimulated by the advent of Zequinox, the licensing of Zequinox. But I don't think anybody anticipates that Zequinox is the lone single arrow in our quiver. We expect and anticipate that there will be additional efforts to identify other control agents to provide a backup so that resistance and tolerance to any one agent doesn't build up. So that's part of the ongoing effort as well. With that, I'm going to stop, and in a moment I'm going to turn it over to Mark. But at this time, I just want to pause and ask if Bob Lamb or John Bratton are available on the phone, and if you have any comments to make before we turn it over to Mark Gaikowski. Are John and Bob able to chime in, Erica, if they're on the webinar? Are they unmuted?
I'm sure they are.
John Bratton or Bob Lamb, are you out there? I know Bob is traveling across Canada this morning and may have some phone difficulties. John Bratton? Okay. Well, we're not hearing from either of them. They've been very helpful in helping us think about and plan the collaborative at this up to this point. So they're with us in spirit. Okay, at this point I'm going to introduce and turn it over to Mark Gaikowski. Mark is Center Director for the Upper Midwest Environmental Sciences Center with USGS, with some updates on the science.
Well, good morning, everyone. And again, I'd like to express my gratitude for all those folks that got up this morning and chose to participate in this webinar. So we very much appreciate your participation in this. John, can you guys hear me okay? Or Erica, you guys can hear me okay?
Yeah.
Okay. Well, first off, we're going to start off talking a little bit about some of the background about Zequinox, its discovery and registration, and then we'll get into a little bit more of the science that we've been looking at and evaluating in terms of the potential use of Zequinox for management of descended mussels, and then talk more about some of the science needs we identified for the potential collaborative that we're moving forward with. So next slide, please, Erica. Erica, can you go to the next? Okay, thank you. So just a little bit of an outline of the presentation. We'll talk a bit about about Zequinox, some background information for it, some of the different projects that USGS has been conducting in collaboration with partners from New York State Museum and from Marine Bioinnovations, and a number of other public partners to move forward with our Zequinox work. And then also talk a little bit about some of those challenges that we identified to understand how we might move forward with the Dreissena mussel management program. Next slide, please. So a little bit about the background on Zequinox. I'm pleased to note that we've got Dr. Dan Malloy, who led the team that identified Pseudomonas fluorescens, strain CL145A, from some backwater, from some river sediments in the northeastern United States. Dan and his team were looking for tools that could be used as an alternative to the oxidizing chemicals that have been previously used and implemented to control Dreissena mussels in industrial water control systems. Dan and his team were modeling their research on some of the black fly control research that have been developed for bacillus, which identified Bacillus thuringiensis as a control for black flies and other insects. And they were able to isolate this strain of Pseudomonas and found that it was very effective against all Dreissena mussel life stages. And subsequently, they were fortunate enough to have the product licensed by Marine Bioinnovations out of Davis, California for product development and commercialization. Next slide, please. Well, exactly how does Zequinox work, or the Pseudomonas fluorescens work? Well, Dreissena mussels take up the particles, or take up the bacterium and perceive it as food. They siphon it into their digestive glands, and where it has its impacts on the epithelial cells lining the digestive system of the Dreissena mussels. And you can see on the photomicrograph on the left of the screen the healthy digestive tubules of a Dreissena mussel digestive gland. On the right of the slide, you can see a photomicrograph of digestive tubules of a Dreissena mussel that has consumed the Zequinox material and is undergoing substantial necrosis of that epithelial lining and hemorrhaging, losing blood cells out into the lumen of the tubules and basically proceeding on towards death. So it has its effect primarily on the epithelial cells of lining that digestive muscle, lining the Dreissena mussel digestive system, and causes death somewhere between 21 to 28 days after exposure, depending on water temperature and the exposure concentration. Next slide. Current registration status. So Zequinox was registered for use in closed systems in March of 2012 in the U.S. There are to date 30 individual state registrations completed for that use. And the way it was defined is that it was registered for use in systems that had a defined inlet and outlet. So basically any power plant cooling systems, water service systems, etc. In June of 2014, which is why one of the primary reasons why we started thinking there might be some potential for open water uses, is that Zequinox was registered in the U.S. for use in open water systems. And to date, there are 8 individual state registrations that are completed that allow its use in both lakes, streams, reservoirs, etc. And Marine Bioinnovations is moving forward with obtaining additional state registrations. It's also registered for use in Canada back in 2012, the same time frame that it was approved for the initial registration in the U.S., again for use in hydropower facilities. Next slide, please. So a little bit more about Zequinox. The product is comprised of dead cells. I think this is one of the original goals of the initial research team that Dan put together, was to identify a bacterial product that could be used without having to have a live cell present. So in the current formulation, the current commercial product, there are no live bacterial cells present. So there's no concerns about growth of the bacteria or reproduction of the bacteria once it's released into the environment. It's considered to be not a human pathogen. The bacterium is categorized both as a biosecurity level 1 and given the lowest possible risk rating by the 2 rating entities within the U.S. In terms of biosecurity or biosafety. The product is considered by the US EPA to be food tolerance exempt, meaning that the waters that are treated with Zequinox could be applied as irrigation waters to crops, and there is no requirement for a food tolerance for it, so the foods can be used, the agricultural products can be used immediately after treatment, and there's no re-entry interval after treatment for access to water that's being treated for the public. Next slide, please. Zequinox breaks down relatively quickly within 24 hours of rehydration of the dry commercial product. The material loses its activity to cause mortality in zebra mussels and quagga mussels. It's considered to be non-toxic or practically non-toxic to mammalian and avian wildlife through studies that were conducted by MBI and others to support the registration. It's been identified to have low toxicity to freshwater organisms, and it's found to be readily biodegradable and is non-corrosive to metal materials, etc. Next slide, please. So now a little bit about the projects that USGS has been participating in and evaluating Zequinox for potential open water uses. We've received funding from a couple of different fund sources, notably from the Great Lakes Restoration Initiative and from the Legislative Citizens Commission on Minnesota Resources from the state of Minnesota and their Environment and Natural Resources Trust Fund. First, on the GLRI projects, those suite of projects were focused on limited open water uses, primarily focused for native mussel restoration and use during fish transport so that fish hatcheries could more readily move fish between lakes or to lakes with reducing their risk of transporting zebra mussels or quagga mussels in their transport water, and then also expanding out the efficacy and non-target effects databases for Zequinox. In the second grant, we're primarily focused on looking at evaluating some application techniques and methods that might support the use and application in open water systems, and then also, again, looking at some additional non-target effects information for species and life cycles that had not yet been evaluated. Next slide, please. So I'm not going to talk through each of these individual species or sets of studies, but I'll just kind of give you a broad overview of some of the studies that we've done. For looking at effects of native mussels, we assessed the effects of Zequinox exposure on 7 different species of juvenile to subadult native mussels and found over 95% survival on all the species that we tested at this life stage. We also completed studies on the juvenile Clochidia, and then also on newly transformed juveniles, and found very good survival, except in the extreme exposure scenarios with those life stages as well. Next slide, please. We also completed additional non-target work with native mussels in field settings by conducting some exposures of native fat mucket mussels in a small Minnesota lake over in Lake Darling, Minnesota, with 2 different groups of native mussels, one with zebra mussels that had been adhering to them removed, and one with native mussels with the adhering zebra mussels retained on the mussels. And we had very good survival in both cases, with only a small decrease in survival at the highest exposure of 100 milligrams per liter, and that's in mussels that were over 50% encrusted with zebra mussels adhering to them. Next slide, please. We also conducted exposures with a number of different species of freshwater fish. Since this work was funded with funds from the Great Lakes Restoration Initiative, we've primarily focused on species that were important to the Great Lakes region. Again, we only saw impacts at concentrations and exposure durations that well exceeded the proposed labeled use for application in open water settings. Next slide, please. We've also initiated work in 2014 looking at the potential impacts of Zequinox exposure on a number of additional aquatic invertebrates, notably Hexagenia mayflies and Gammarus amphipods, and have seen no observed effect on survival of those species. We also initiated studies to assess the potential impact of Zequinox exposure during spawning of freshwater fish and found no effects to date on spawning success or embryo hatchability or embryo hatch to date in those studies. Next slide, please. I should mention just briefly that for the last slide, Eric, if you could go back one. The fathead minnow studies that we're conducting, we're actually retaining the offspring from exposures where the eggs and adults were exposed. We're retaining those larvae and growing those juveniles up, so we'll attempt spawning of those fish the summer of 2015. So that we'll be able to look at the potential repeated effects of exposure to Equinox in the same cohort of fish. Next slide, please. So now we'll get into a little bit about some of the effectiveness trials we've conducted. We completed 2 different trials at Lake Carlos and Shawano Lake. Lake Carlos is a probably considered a mesotrophic lake in western Minnesota. Shawano Lake is a eutrophic system in central Wisconsin. We tested, again, 50 and 100 milligrams per liter of Equinox as our exposure concentrations, and we looked at different exposure durations to see how long of an exposure would be required to obtain the desired effect. In the trials in Lake Carlos, we identified that even the 6, 9, and 12-hour exposures were relatively equally effective, whereas in Shawano Lake, where there's a greater amount of other materials present in the water column, we saw a slight decrease in the response of, or slight increase in survival at the shorter exposure durations in that lake versus in Carlos, but still greater than 90% mortality in all of our treatment applications. Next slide, please. One of the other things that we wanted to assess during these trials was the ability to target the application to where the zebra mussels are. So in both Carlos and in Shawano, we tested what we considered, or what we described as a whole water treatment or application and a subsurface application. In the slides, the 4 bars represent the treatment levels at the 2 different lakes. So on the left side, where it says 50 milligrams per liter, the tannish bar and the light blue bar are the 50 milligrams per liter treatments at Carlos, the whole water down at about 1% survival or less than 1% survival, and the subsurface application at about 18% survival. And then the yellow and gray bar are the same applications at Shawano. The difference, one of the reasons why we think that the Shawano applications appear to be much more effective is that we improved our application approach between Carlos and Shawano. At Carlos, we used a more concentrated stock solution, and we didn't achieve the same amount of mixing within the targeted treatment zone, whereas in Shawano, we used a slightly slightly lower concentration stock solution and had much more effective mixing around the treatment zone, and therefore delivered a much more effective treatment during the applications at Shawano Lake. Next slide, please. Again, going back to the study in Lake Darling in Minnesota to look at the potential use of Equinox in native mussel restoration, this is the first time, to our knowledge, that native mussels with adhering zebra mussels had been treated with Equinox, and we were able to reduce the zebra mussel infestation rate or attachment rate by between 53 to 68% with no impact on native mussel survival. One caveat on this study is that there was a substantial algal bloom that occurred during the trial and caused us to actually shorten the post-exposure observation period to about 14 days instead of the preferred about 28-day post-exposure observation period. So there may have actually been zebra mussel mortality that we were not able to observe occurring that may have occurred in those additional 14 days post-exposure, but we couldn't leave the native mussels in that location because the algal overgrowth may have compromised the study. Next slide. We've also, again, going back to Minnesota, we were able to conduct some studies in Lake Minnetonka, again, looking at the ability to target the application using subsurface application methodologies relative to whole water applications so that we could attempt to reduce or minimize the amount of Zequinox that would need to be applied to achieve control. And in using zebra mussels that were attached and affixed to artificial substrates and also on natural substrates, we compared the whole water applications versus subsurface applications. And again, we saw pretty decent mortality in both treatment groups, with about 70% mortality in the whole water treatment group and about 65% mortality in the subsurface application group, with really no significant differences between the two application techniques. The one significant difference that did occur was in the amount of material that we used. We used about 50% less material in the subsurface application than the whole water application approach. Next slide, please. Looking at the natural substrate, we actually saw a little bit bigger difference in the percent reduction, but when converting that over into the number of zebra mussels that were killed relative to the mass of Zequinox that was applied, you can see there's a substantially greater number of zebra mussels killed per gram of Zequinox applied when doing the applications with a subsurface application technique than the whole water treatment application technique. Next slide, please. We also went back to Lake Minnetonka again this year with the funding from our friends at Minnesota at the Environment and Natural Resource Trust Fund. Looked again at increasing our open water enclosure study size, going from about a 1.5 meter enclosure up to about a 9 square meter enclosure. And we again compared subsurface versus whole water application techniques. This time we expanded out and we used a number of different substrate types to allow zebra mussels to adhere to and native insects to adhere to. And we assessed not only zebra mussel mortality, but we were also assessing the impacts of Zequinox exposure and Dracaena mussel management on invertebrate community composition. Next slide, please. So getting into some of the challenges associated with transitioning into open water applications. As many of the folks on the phone will know and understand, moving into open waters brings you into a very dynamic environment. As we've identified in our enclosure studies, lakes and larger water systems are extremely dynamic. Wave action from wind or from boats can cause mixing in the enclosures. There's variable water depths that we need to contend with as we move into those open water applications. And if we're going to continue to move forward with an approach that requires containment, we're going to be limiting ourselves somewhat to focusing on small, shallow water areas. One of the things that we need to identify and refine are some of the contact time duration parameters that will more effectively allow us to apply Zequinox or other controls in those types of environments. Focusing again on Zequinox, because that's the product that's available for use, or one product that's available for use right now, we need to understand how we're going to mix and some of the logistics that are associated with doing the actual application, so that we find the right exposure concentration, the right stock solution concentration that will allow the product to be placed in the water column at the concentration and at the duration that we need to achieve. Next slide, please. With Zequinox, we've expanded out the non-targeted effects database quite nicely, but there are a few key invertebrate species and also some early life stages of fish that are likely to be very important for us to conduct some non-target effects studies on to make certain that as we move forward and we start doing some of these larger, potentially larger applications, that we're not compromising any of those critical communities. We also need to understand what are some of the impacts of a larger Dracaena mussel management or control effort on some of the water chemistry and water quality parameters that are important to our native vertebrate and invertebrate aquatic communities. What are going to be the oxygen demands required if we go out and apply Zequinox or some other control mechanism to a large Dreissenid mussel community that if we're effective at killing even 60 to 70% of the Dreissenid mussels present in the location, there will be substantial oxygen demand required and a pretty, potentially a fairly immediate nutrient boost to the system from the degradation or necrosis of those dead and dying Dreissenid mussels. And what will be the impact on Dreissenid mussel filtration? Because we know that Dreissenid mussels are very effective filter feeders and are taking out a lot of particulate matter in the water column. So what will be those changes associated with control or management of Dreissenid mussel community? We also need to identify and focus on some different management outcomes. What will be those desired outcomes that managers have? Are they going to be focused on restoring native mussel and fish spawning habitat? Is it going to be more focused on altering Dreissenid mussel altered nutrient cycling or impact on harmful algal blooms, or is it going to be focusing on restoring ecosystem functions and services to something of a pre-Dreissenid mussel or closer to a pre-Dreissenid mussel invasion system? Next slide, please. So what are some of the future research questions that we need to also focus in on in terms of controls? Well, we talked briefly about better understanding some of the application and dosing and environmental effects for open water applications. We're also, through the Great Lakes Restoration Initiative, evaluating whether and how we might be able to capture different toxicants within a microparticle application that could be applied to filter feeding invasive species such as Dreissenid mussels. We're also evaluating current molluscicides such as niclosamide and how it might be used in a broader Dreissenid mussel management program. Folks at the Great Lakes Science Center, Nick Johnson, is looking at, with some other university partners, looking at how algal components might be used to disrupt spawning synchrony of Dreissenid mussels. And we're also identified that we need additional tools. I think Tim pointed out that we need additional arrows in the quiver. So trying to identify other physical, chemical, or biological tools that could be used to control or manage Dreissenid mussels. We also recognize we need to be able to evaluate the impacts and use of those controls. So we need to have some baseline ecosystem data to be able to assess what does the system look like now and how can we change it back to what it hopefully was in the past prior to Dreissenid mussel invasion. We also need to be able to conduct and evaluate some small to large-scale applications of these different controls so we can understand the effectiveness of those controls and the impact on bringing the community back to a desired end state. We also need to assess those post-treatment outcomes and define our retreatment intervals so we understand how frequently we may have to go back in and apply a control or a management tool to be able to keep Dreissenid mussel levels at the desired management end state. Next slide, please. To support this, one of the things that we've discussed is that we do need some models to help predict what our desired outcomes are going to be and going to look like. With zebra mussels, there's a pretty decent population model that's been developed. For quagga mussels, that information or that model doesn't exist in a similar of a fashion. So we need to develop a better quagga mussel population model. We also need to develop a predictive distribution and abundance model that will help inform where and when we should be able to, where and when we need to do the treatments and inform our retreatment modeling efforts. And that goes hand in hand with being able to link our controls and the application of those controls with those predictive distribution and abundance models. And we also need to identify and define what an acceptable Dreissenid mussel load might look like for managers to, as they consider those, whether to treat or not to treat. And then we also identify we need to refine the surveillance tools and techniques that are being used for Dreissenid mussel management, especially where those tools might be able to be used to help inform control efforts and management efforts. Next slide. And I believe that's my last slide. And Tim, I'll turn it back over to you.
Very good. Thanks a lot, Mark. We are going to have an opportunity to take questions here in just a moment. I just have a couple of concluding remarks to make. So I just want to make a couple comments about what's going to come next with our plans for this collaborative. Obviously, ongoing communication and feedback. We want to know from you, does this approach make sense, and what are your interests and priorities? And to facilitate that, one of the things that we've used in the past, we're kind of modeling this effort after a successful collaborative that we've created in partnership with USGS around Phragmites. And one of the things that we did early on is create a simple survey, and that survey you can see on the screen right now that is available on the website right now. So that's a simple and easy way to give us feedback on priorities and on the shape and structure and function of this collaborative. So we are planning a first meeting of the collaborative sometime in February, date to be determined. There we will be, again, talking further about the research and research needs, defining a common agenda, management objectives, and so on. And throughout this period, we'll be reaching out to stakeholders regionally, nationally, and internationally. So at this point, we are happy to take your questions. Again, if you have a question, you can click on the raise hand button and wait to be called on. Remember to unmute your phone before speaking, or you can type in and submit a question in the questions box in your webinar control panel.
Can I go back to Bob briefly?
Sure. Is Bob Lamb on the phone? Bob Lamb from the Great Lakes Fishery Commission. Have you been able to log in?
Can you hear me now, Tim?
Yes, we can, Bob. Anything you want to say about this effort?
Yeah, thanks, and I apologize for the technical difficulties here. I wasn't able to get unmuted when you were asking for my comment before, but I just want to make a comment to support what you, Tim, and Leon had covered before. You certainly did it very well, and also compliment you, Mark, on the presentation. I think this is the third time I've heard a variation of the presentation, and I learn, immensely from it every time I hear it. But just a quick word, perhaps, on why the Great Lakes Fishery Commission jumped on board the collaborative as a founding member. We had all but given up on finding a way to manage zebra and quagga mussels, but recent discussions with USGS, in particular, regarding the research that they've been doing, a lot of what we heard about from Mark. And more recently, information we've seen or we've been seeing about the evolution of Zequinox as one possible tool for potentially managing dracinids, at least in some settings like closed systems, has really gotten us talking again about possible management opportunities here. So, that said, there have been a lot of questions that need to be answered before we speed along with any kind of large-scale management. For example, what effect will dying and dead mussels have on oxygen and nutrient concentrations? What effect might these changes have on native fish populations, and so on? Some of the questions that Mark spoke to. We believe the collaborative is really an effective mechanism to bring the right people together to link research to management, so that we can move forward in an informed manner, maximize the precious resources that are available to us all. So I think it's the right way to go about addressing this widespread problem, and really thank everyone for joining us today. Thank you for your interest. So with that, I'll turn it back over to you, Tim. Thank you.
Okay, thanks, Bob. We have a number of people that have submitted written questions, and one person that's raised their hand. We're going to take the written questions first. And so, Erica, would you read the questions?
Sure. So the first question is, would you also consider risk assessment and invasion prevention for the golden mussel?
Yeah, this is Leon, Carl. I don't know if Mark wants to chime in on that. We've certainly thought about that one. We haven't, as far as I know, we haven't been looking at testing the silver bullet Equinox on that particular mussel species, but I will say that Mark mentioned just tangentially that we have been working with Asian carp on microparticle technology, which basically allows us to construct a capsule that we put a known general toxin in there. For example, this time we're using endomycin to treat Asian carp and having some success with that. I could see the point where we could certainly search for an individual silver bullet such as we have with Equinox, or we could look at microparticle technology to use a more general molluscicide like miclosamide to go after golden mussel. Again, that would be a question that we could look at as we move this forward. Mark, did you want to add to that?
No, I think you captured it well, Leon.
So the next question has a comment associated with it, and it's regarding invasive mussel efforts in the West. And it's been noted that there are some collaborative efforts in the West, and they have been looking at reaching consensus on definitions and protocols for watercraft and decontamination programs, establishing legal and regulatory approaches, and opportunities for invasive species abatement and reform. So these groups are collectively identifying research priorities and may overlap with some of the Great Lakes efforts. So the question is, where will funding for the new collaboratives come from, and will any of it be directed to Pacific Northwest or Western states to participate in advanced efforts?
What I hear in that question is a more general interest in control, management, detection, response to mussels, and those efforts are terrific and important. We've been struggling with those challenges here in the Great Lakes region for 2 decades now. This effort at the outset is going to focus on control technology, specifically with Equinox and potentially other agents. Our initial funding is from the Great Lakes Restoration Initiative, and USGS, and so that's going to be the initial focus. But yes, we will, as we move on and expand and build on what we hope will be a successful effort, we will look both beyond this immediate region, beyond the Great Lakes region to the west, but potentially at other aspects of zebra and quagga mussel control and management techniques and technologies. But at the outset, we're going to start with control technologies around Equinox.
I would just like to add to that. I think it's really excellent that we do have that work ongoing in other parts of the country as well as some places here within the Great Lakes. And adding that will only strengthen the Invasive Mussel Collaborative as we move forward. A lot of what we mentioned at the beginning was looking at it from an ecosystem perspective in systems that had already been invaded. But I think looking at it broadly, those kind of things that you guys have already moved forward on and reached some consensus on, I think would be really excellent in partnership with the rest here.
So the next question, and I believe this will be for Mark, but it's please define what you mean by subsurface application. And then following that, how does it differ in amount and difficulty of application compared to whole water application?
Okay, so subsurface applications are basically trying to target the application zone to the area in the water column in which zebra mussels or quagga mussels are present. So for our treatment applications, we were targeting basically the bottom third of the water depth or the water column to achieve a target concentration of between 50 and 100 milligrams per liter Equinox in that location. In terms of difficulty, there are a lot of challenges that are associated with both application techniques. In an enclosure, a whole water treatment application might be easier because you're already mixing the entire water column at the desired or target concentration. But in a subsurface application in an enclosure, wave action impacts the concentration that you achieve in that enclosure. In some regards, in an open water application, in an unconstrained application technique, if you could map out and utilize any currents or water flows to your advantage, you actually might be able to be more effective at a subsurface application to deliver the desired treatment concentration. I guess my other comment would be that I don't think either of these applications are going to be easy, regardless of which one you elect to use.
So, Mark, I'm going to follow on with that question with this next one. Is there any difference in the biological activity of Zequinox in open water versus subsurface treatment?
No, there isn't. We're using the same, excuse me, the same exposure techniques or same application techniques. You're trying to achieve the same exposure duration, so there is no difference that we've identified in between the biological activity between a subsurface and a whole water application.
Okay. Next question. In terms of determining human safety, do you know if the federal reviews considered exposure via drinking water?
Mark, you know that one, or Leon?
Leon, this is Mark. I'll try and answer this one. I think we may have Megan Weber on the line from MBI, and if we can, we might want to have her send in a note. I can't speak specifically whether the registration looked at use in drinking water, but it's my understanding that most of those exposures looked at both mammalian and avian responses, and the EPA concluded that there was no requirement for a tolerance to be established, and that's a pretty high bar to be set for a pesticide registration.
Megan, if you can hear me, I unmuted your line if you want to comment on the exposure pathways that were considered.
Sure, yep. You know, I would have to double check what the EPA standards are. We don't have our regulatory person on the phone, but Zequinox was, when they went through their reviews, one of the approved areas of control is on drinking water infrastructure and facilities. So if that helps answer the question, I don't know the specific test, but that was concluded an acceptable area to treat.
Thank you, Megan. So I'm going to switch to, we have one raised hand from Daniel Malloy. I'm going to unmute you. You should be able to ask your question now, Dan.
Yes. Can you hear me clearly?
Yes.
Okay, good. I just want to make a comment, what Mark has said, that Zequinox, you know, is not, and others have said, it's not the single arrow, it's not the silver bullet, it's a tool, and a very valuable tool because of its specificity in the IPM tool chest. The other comment I want to make is that in open water, I do see it restricted to high-value areas. All pesticides cost money, Zequinox included, so there could be cost considerations and also potential oxygen demand issues, which would not exist when power plants are being treated. I have a question for Mark, and that is, lake associations that I deal with always have the question, what are you going to do to reduce zebra mussels in my entire lake? And I noticed, and I was pleased to see that Mark listed other types of biological control tools that he's envisioning. And what would they be, Mark, for lake-wide control, which, by the way, I think is critical towards stopping the spread of the mussels? What are you envisioning lake-wide?
Dan, that's a great question, and thank you for asking it. You know, at this point in time, we're very open to you know, ideas and thoughts being put forward by other members of the collaborative. We see the value in the collaborative coming up with some of those some questions and potentially answers that we may not have identified. One of the things that you know, that we're looking at right now in terms of a biological control is the spawning desynchrony that I talked about, that Nick Johnson at Great Lakes Science Center is working on. If we can try to minimize excuse me, reproduction and recruitment, that would be one kind of lake-wide application that may be very useful to us moving forward. combined with other tools that we might bring together in an IPM or integrated pest management approach to addressing zebra mussel and quagga mussel challenges. So I don't have a specific answer in terms of what is the next type of biological control that we ought to be looking for. I think we should be looking at a number of different options that might be out there on the table.
Thank you.
Thank you, Dan and Mark. Next question. Will this collaborative be reported as an outcome from the multi-Great Lakes Water Quality Agreement annexes that it can be applied to?
Well, we'll know the answer to that by the end of the day tomorrow. I was not planning on making a report out on this. I'm part of the Annex 6 working group, but I would suspect that it will be discussed up at the meeting in Toronto, but we'll know shortly.
There have been a couple questions related to mortality. It was noted that one of the slides showed 90% mortality and not 100%. So the questions are, has there been any documented resistance to Zequinox, or have you seen any poor mortality over time?
So I'll take this question, and again, Megan, if you'd like to chime in, I think that would be appropriate. We have not observed any, well, we have not conducted any studies to be able to identify whether resistance might or might not occur. Our studies have been single exposure studies and then monitoring for post-exposure effects. That's one of the things that we identified as part of our discussions in establishing the collaborative, is that we do need to conduct some exposures, look for survivors, retain those survivors, and then do additional exposures to see if those survivors are or are not resistant, whether they would pass that resistance along, and if it was just a simple fact that they were not feeding during the exposure period and thus didn't get a lethal dose delivered to them. So that is a question we want to address, but it's one that to my knowledge, data don't exist, at least the data that we've not seen.
Megan, you're unmuted if you'd like to add anything.
Sorry, on phone as well. Yeah, I think Mark sums it up pretty well. We haven't done, I guess we haven't been in lakes long enough to do long-term resistance studies, but one of the nice things about most biocontrols is that they typically have a more complex mode of action, so it's more difficult for targeted species to develop resistance. That doesn't mean that it's impossible. So, you know, I can't say no, it definitely won't happen, but it's, you know, so far we haven't seen it.
Thank you. So next question, Dreissenids have been present in Europe for over a century with good evidence of adaptation by invaded ecosystems and coexistence, for example, with native mussels. Should we be doing more to model the long-term prognosis for coexistence and long-term change?
I think that's a good question and a good suggestion, and something that we should discuss and consider, and probably add it to the list of research questions.
Okay, next question. Are plans in place to test Zequinox in river systems?
Mark, can you take that?
That's another great question. I'm glad we're getting all these good ones to stimulate our thoughts for the collaborative. You know, we've discussed a little bit. I think it would be really challenging to try to apply Zequinox within a river system just because of the constant flow that you're going to be having in that location. We have thought about potential uses. There's a native mussel roundup that occurs in the Wisconsin River annually, and that might be a location where some of the native mussels could be treated in their beds to reduce Dreissenids mussel burden on those native mussels. But I think that's a location where the flow is a challenge, and we have to take into account the logistics of completing the treatment and the costs associated with it versus the return. So It's a great question and one we need to consider. It's not certain right now how we can do that in a cost-effective and efficient manner.
Okay, I have two questions, again, related to mortality. One is Zequinox equally effective at killing both zebra and quagga mussels? And then also, relatedly, is there a hypothesis for why there is mortality for dracenids, but it's different for native mussels?
Megan, do you want to speak to the zebra and quagga mussel mortality question?
Yeah, I can't see any difference between the two. We have test sites in areas that have both zebra and quagga mussels, and both have been able to achieve very high levels of control.
And any reason, any hypothesis as to why there's mortality for dracenids but not native mussels?
Oh, sorry. No, there was a study done. If Chris Barnhart's on the line, actually, he might be able to answer that. He and his graduate student, Madeline Pletta, did some work there to look at what the difference may be.
It doesn't look like he is.
Okay. I will. So when they did their work, one of the big questions was if it was just an issue of particle size. So they had tested if the native mussels were ingesting the same particle size, and if they were ingesting, Zequinox-sized particles and Zequinox itself when they did their studies, and they found that they were ingesting it as well. So it's not just a matter of the physical size of the particles. Aside from that, we've been able to eliminate that as a reason why, but why it's so specific? No, we don't have anything else there.
Anything else to add, Mark?
Yeah, we had a graduate student working on looking at the digestive enzyme characteristics between native mussels, dracenid mussels, and aquatic invertebrates in the upper Miss. And one of the things we noted was that there are significant differences in the digestive enzymes between the digestive enzymes present in the digestive tubules of dracenid mussels versus native mussels. And so what that might lead us to believe is that native mussels might actually be feeding on different food sources than dracenids. So the dracenids may be retaining the Zequinox, whereas the natives may be not using and not focusing on it as a food source. So they may be reducing their exposure. That might be one theory as to why we're seeing a difference in mortality between the two species.
Thank you. Next question, given the long-standing contributions of the regional aquatic invasive species panels in coordinating research activities, how does the proposed collaborative do anything different and avoid duplication of resources and effort? All of the organizations represented are affiliated with the regional panels, and lessons learned are that approaches to AIS management control often vary among regions.
Yes, this is Tim. I would say that the approaches do vary from region to region, and if in the West or other parts outside of the Great Lakes region, if it makes sense to coordinate the types of questions and the effort that we're proposing for the Invasive Mussel Collaborative through the regional panels in the West, then by all means you should proceed accordingly. However, I think for the purposes of us in the Great Lakes region, it makes sense to have an Invasive Mussel Collaborative because the agenda and the activities that are brought before the Great Lakes Regional Panel are just more than what can be. This Invasive Mussel Collaborative is going to require more time and effort and an intense, focused effort, more than what the regional panel can provide. That being said, there have been, we just had, the Great Lakes panel just met. We had a presentation on the Invasive Mussel Control Collaborative. There was a great deal of interest. There is going to be a great deal of overlap, but we think it makes, and we will continue to coordinate with the panel, but we believe it makes sense to have a focused effort around invasive mussels.
Okay, next question. The use of Zequinox seems that it may be useful at small scales but prohibitively expensive at large lake-wide scales. Would there be plans for large-scale deployment in open waters of the Great Lakes?
This is Leon Carl from USGS. I'll take the first crack at that. I really think that part of the reason for having the collaborative is to sit down and see what our management objectives might be as we move this forward. And that would certainly be part of that equation that we would look at is the cost of treatment. I don't know what the economies of scale for production are right now and how that might change. We've also talked about the issue of a second, in other words, creating a toxic suite of chemicals rather than a single chemical in treatment plants, or using just a general niclosamide, for example, as a molluscicide at times as well. So I think a lot of those questions we're going to be tackling as we move this forward, and it's very difficult to look at this point. I would emphasize that we have, there certainly is precedence for large-scale applications of things. I'm not sure it's at the same scale, but it's large-scale. And the one that I'm most familiar with is the sea lamprey control and the effort that's made on the Great Lakes-wide basin moving forward. We're not anywhere near that now, and I'm not sure that we will ever get there, but we could certainly envision that kind of effort if these things make sense and if the management agencies are interested in that approach.
So related to this, there's been a question about has there been any economic or cost-benefit analysis associated with treatments of Zequinox? And it might be something for the collaborative too.
I would suspect that they are out there. I'm not aware of them. We just did some back of an envelope kind of scratching, and I think one easy place to get numbers is to start to look at the cost of treating infrastructure around the Great Lakes, for example. And if we start to look at that and look at the magnitude of cost there versus some sort of a reduction in the need for that treatment, you can start to see that there is a lot of money that is expended there. Another example would be the often quoted number of $7 billion fishery on the Great Lakes. If we could change the trajectory of the ecosystem to the point where it benefited some of the native fish that people find of value, we again could see quite a difference in the cost benefit from the standpoint of how much it costs to treat a portion of a lake perhaps, and the benefit to a fishery.
So I'm going to go back quickly to the difference in mortality on different types of mussels, as Dan Malloy had something he wanted to add to that discussion. So Dan, you should be able to go ahead now.
Yeah, I agree with Mark's hypothesis that conditions in the digestive tract between the unionids and dreissenids are probably different, and here's some evidence for that.